Okay, so this is a video on writing conclusions in non-technical terms. Um, so when you do hypothesis testing, things get down and we strip away all of the humanish kind of language from it and we make it something that is without bias and pretty analytical. Um, so let's try this. The basic idea here is that you're not going to tell like somebody in the world that, hey, I did a hypothesis test and it failed the null or whatever. We rejected the null. So let's see what we've got going on here. Your audience. So let's try something here. Let's say that the claim is that the average age of Major League Baseball players is 30 years old. Okay, so in statistics land, this would be the null hypothesis is that the mean is equal to 30. The alternative hypothesis is that the mean is not equal to 30. And let's say we go and we do some analysis of data and we find that the actual mean has to be between 30.062 and 30.538. Now, in StatsLand, that says reject the null hypothesis because it's not possible for this to be true on that interval, right? 30 does not fit between 30.062 and 30.538. So, what would we say to the rest of the world here, though? We would say that the data does not support that the average age of a Major League Baseball player is 30. Okay, we don't say that we reject the null, we just say that the data doesn't support the claim. Okay, so this is how we kind of put it into average, ordinary, everyday language. So let's look at another claim about baseball players. Okay, so the claim here is that the percentage of Major League Baseball players born outside the United States is 29%. So again, we can write this as a null hypothesis where the percentage is equal to 0.29. The alternative hypothesis is that the percentage is not equal to 0.29. And then we look at the data, and the data gets analyzed, and it says that, well, given a sample of 100 baseball players, we found that the percentage of them, the percentage of the population that is born outside the United States should be between 21% and 38.9%. So what does this mean? This means we fail to reject the null hypothesis, but that doesn't make sense in ordinary everyday language. So what we do say is that in this case, the data supports the claim that 29% of the Major League Baseball population was born outside of the United States. Now, it supports the claim. It does not mean that it proves that claim, but the data does support it. Okay, so unless we have other data that denies that claim, so far we're in good shape. So let's look at one last one. Both of these have been like two-tailed, not equal to kind of tests, and the claim has lived in the null hypothesis. Let's look at one that has a different type of inequality. Okay, so let's make a claim about the heights of Major League Baseball players. I'm going to say that the heights of Major League Baseball players are above 74 inches. So my null hypothesis always has to be an equivalent statement. So we're going to say that the average height is 74. And then we're going to say that the average height is above 74. So note, in this example, the claim is riding in the alternate hypothesis, but we test the null. Okay, so what we do is we test the null, and we find that the mean for the population has to be somewhere between 73.3 and 74.1. Well, that means that number 74 is in this. So we fail to reject the null hypothesis. If I fail to reject the null hypothesis in this case, remember the claim is being represented by the alternative hypothesis. That means that the data here does not support the claim. In fact, the data tells us that the average height could be as low as 73.3. It doesn't have to be, and it can be 74. It can be a lot of things below 74. So yes, it is possible for the alternative hypothesis to be true, but because we failed to reject the null here, this data set does not necessarily support the claim that we're making. All right, so this is the idea of expressing our conclusions in non-technical terms, and there you have it.